C11, I would like to do the very common function here that shows up a lot. And that common function is 1 over 1 plus x. So I'll make a table again where they have the n, 0, 1, 2, 3, 4, 5. And I'm going to expand this about x equals 0. So this is going to be a Maclaurin series for us. I'm going to have here the derivative, nth derivative of the function at x, and then I'm going to evaluate that at x equals 0. And then here, I'm going to list the nth term in the series. So the series here, I'm going to write down at the bottom here, f of x is equal to f of 0 plus the first derivative, and I'll use the standard notation here, times x, plus the second derivative evaluated x, that's going to be over 2 factorial, x squared, and so on. So the next one would be the third derivative at 0 over 3 factorial, x cubed, and then got to put down the parentheses there. The fourth derivative evaluated 0 over 4 factorial, x to the fourth. So what's the function? Well, here it is. F of x is this one. So if I put in the 0, I'm going to get 1. But to keep the table accurate, no derivative means 1 over 1 plus x, and if I put in 0 for x, I get 1. Now, the first derivative, you can think of this as 1 plus x and a minus 1. I'd pull the minus 1 down, so it'll be a minus sign. And then we would divide by 1 plus x squared, and we would take the derivative of what's inside, which is going to give 1. The derivative of the constant 0 and the derivative of x with respect to x is 1. So that's the result. And then if we put in 0 for x, we get minus 1. Now if we're going to do the term here, the first term is just the f of 0, so that's going to be a 1. The next term is going to be what we have in this column times x. So this will be a minus x. And let's do the next one. Well, if I want to take the derivative here, I'm looking at a minus 1 plus x to the minus 2. So the minus 2 comes down, kills that minus sign. So we'll have a 2 over 1 plus x in the denominator cubed. Because you bring the minus 2 down and then you subtract 1 there using our rule. And since the derivative of what's inside is going to be 1, using the chain rule, we get this. Put in 0, we're going to have here a 2. This is going to be a 2. So in the series here, you would take that column and divide by 2 factorial and hit it with x squared. So if we do that, we get x squared. And this next one, we would bring down to minus 3. So this is a minus 3, and there's a 2 and a 1, so that's minus 3 factorial. And it'd be over 1 plus x to the fourth power. And when you put in 0 for x, you would have minus 3 factorial. And then here, you take this column, divide by 3 factorial, it's going to cancel, have the minus sign surviving, and have then minus x cubed. So this one here, the minus 4 would come down, so you'd have 4 factorial, and then you'd have 1 plus x to the fifth power. Put in x 0, you're going to have 4 factorial. And then doing the same thing, you see the factorials cancel. You can consider it as a factorial there. They're going to cancel, so you're going to have here x to the 4th power. So what you're going to have here then for this function would be, you just add these up. 1 minus x plus x squared minus x cubed plus x to the 4th, and so on. And this is 1 over 1 plus x. Now this formula shows up a lot in physics, and when it does, x is often very, very small. So that means that this is approximately 1 minus x, because if x is very small, like say it's like 1 over 100, then this is 1 over 100 squared. That's like 1 over 10,000, all right? Even if x is 1 over 10, this is 1 over 10 squared, it's 1 over 100. So this approximation is often used in physics. In fact, when you see it, you might often see it like 1 plus epsilon, a small quantity, is approximately 1 minus epsilon. I'm going to go ahead and bracket that. Now notice that if epsilon is negative, then you have a negative here and a plus sign up there. So this pair of equations here, very, very important. It's a plus sign, like that. I think it's good to memorize these results. This is very, very important. It shows up so often in physics. See you next class.